This is Unit 7, Lesson 4, and we're on the third part, or the third instructional video, and we are being asked to algebraically determine the x-intercept and to not provide our answer in decimal form. Whenever we find an x-intercept, we're going to set y equal to 0. So right now I'm going to replace y with 0. Now you have the option to also rewrite it where y is on the right-hand side. It's up to you. I'm going to start by here subtracting 3 to both sides. 0 minus 3 is negative 3. And now I'm going to write it in exponential form. So some students like to rewrite this, but this is not necessary. Some students like to rewrite it like this. It's easier for them to put in exponential form when the equal sign and the value are on the right. So it's going to be base raised to the exponent negative 3 equals x minus 5. Now 2 to the negative 3, we're not multiplying that. That says 2 is not happy. It's going to go to the bottom. We know 2 to the third, 2 times 2 times 2 is 8. And now add 8 over to the right-hand side. I have a little more room here. 1/8 plus 5 equals x. Okay, so 1/8 plus 5 equals x. Now, a couple different ways we can do this. I think I'll do the butterfly method. 1 times 1 is 1, plus 8 times 5 is 40, over 8 times 1 is 8. Once again, 1 times 1 is 1, drop down the plus sign. 8 times 5 is 40, over 8. 41 over 8 is the answer. Okay, but before I go into part B, I do want to remind us that when we get this value, we always have to go back up and make sure that it's not an extraneous solution. So when I plug this value in here, and I do the math, remember when we look at log a base a to the b equals c, these two values have to always be greater than 0. So I'm going to test that right now. In parentheses, I have 41 divided by 8, and I'm going to subtract 5. I can see that I still have a positive value. That means that this value does work. Let's look at part B. Okay, I'm going to start by defining the x-intercept, replacing y with 0. And this is like a negative 1. And I'm going to subtract 6 from both sides. And really we're following PEMDAS here. So please excuse my dear Aunt Sally. So I'm starting on the side that contains a variable, and I'm adding or subtracting first. I've subtracted 6. Okay, now outside the parentheses there's nothing more to be added or subtracted, so I move on to multiplying or dividing. We are going to remove the multiplying by dividing. Negative 6 divided by negative 1 is 6. And now it's time to rewrite this in exponential form. You can leave it like this, or feel free to write it in this form. So we have base raised to the exponent equals this. Now, off the top of my head, I don't know what 5 to the 6th is. I'm going to check it out. It's 15,625. 15,625. I'll subtract 3 from both sides. So 15,622. And I'll divide by that negative 1. Negative 15,622 is what x equals. But before we can confirm that's the correct answer, I've got to come up here. And this is the area I'm working on. Now when I take this negative value and I take it times a negative in out front, so it's looking like this in parentheses, negative 15,622 plus 3. I know right away I'm going to get a positive. 2 negatives make a positive plus 3 is still a positive, making this a viable answer. And our final example from this learning set. I'm going to start by replacing y with 0. Next, I'm going to subtract 4 to the other side. And this is like a negative 1, remember? So when I think about the order, please excuse my dear Aunt Sally. I've started by adding or subtracting in order to try to isolate this. Now I'm going to do this multiplying or dividing. So opposite of adding was subtracting, opposite of multiplying by negative 1 is dividing by negative 1. and now it's time to write it in exponential position. Now, if you want to, you can rewrite this as log of 3/2 to the negative x plus 1 equals 4. Okay, let's rewrite this right now. So we have 3/2 raised to the 4th equals negative x plus 1. 3 to the 4th was 3 times 3 times 3 times 3 is 81. 2 to the 4th, 2 times 2 times 2 times 2 is 16. Okay, I'm going to subtract 1 to the left. I have a little more room up here. I'm going to subtract 1 to the left. And so, there are a couple different ways we could go about doing this, but I think the easiest way here is going to be to multiply by 16 and multiply by 16. So now I both have a common denominator of 16, and when I take 80 and I subtract 16 from it, 81, and I subtract 16 from it, I end up with 65. 65 over 16 equals negative x, divided by negative 1. Just simply change the symbol of this entire fraction. So x equals negative 65 over 16. Now, I don't know if this is going to work or not, so let's look. If I take this and I plug it in similar to last time, I already have a negative sign, then I'm going to substitute negative 65 over 16 in for x and then add 1. Well, two negatives make a positive, and then a positive plus a positive, in fact, works.